Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Split Ends by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Each horizontal blonde line sums to a 2-digit number, and those 2 digits are at the start and end of its row in some order. Oh, of its row. It's not at the start and end of its line. It's at the start and end of its row in some order. Interesting. So that means these 5 digits must sum up to a 2-digit number, which is going to be in some way in the start and the end of its row. So say we had, I don't know, a 3 and a 4 here. Then these digits must add up. Okay, that's not going to work. A 3 and a 1? Maybe that could work. That means these digits on this line would have to add up to 31. So you could have something like 2, 5, 9, 8, 7, and that would work, right? 2 and 8 are 10, 5, 9, and 7 add up to 21, so they add up to 31 here. And the 3 and the 1 are in the row at the start and the end of its row. Each vertical brunette line also sums up to a 2-digit number, and those 2 digits are at the top and bottom of its column in some order. So you have a similar thing here, right? Oh, that's funky. Huh. So we have here, these 2-digit numbers must basically either add up to the same number. Well, it's basically it has to add to the same number, I think, right? Because it can't be 2 digits swapped here. These 2 digits, well, it's 2 digits. These 2 digits, sorry, these lines must add up to 2 digits, which are both at the end. That's interesting too. Huh. I'm sort of starting to solve this right now, so that's probably not good. But basically, all of these have to add up to a sum, which is represented by the 2 digits at the top and bottom of the column. And these must add up to sums which are represented with 1 digit as a tens digit, 1 digit as a ones digit, with these 2 digits here. And this is an example of how that could work for just a single line. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have one long line, which means the entire line will sum up to 45. So the ends must be 4 and 5. We have 3 2-digit sums here, which all must sum to the same amount. Because 2 digits can never sum up to 20-something. So therefore, they must all sum to a teen with something with a digit there. So one of these has to be a 1. And then one of these has to be a 1. And it must be 3 sets adding up to the same sum. Well, that could be 11, it could be 12, or it could be 13. So these can't be 11. So it's either 12 or 13 for these sums. So this is 12 or 13, this is 12 or 13, and we cannot have another 1 anywhere in row 1 or row 9, which means none of the vertical sums can ever sum up to anything with a 1 in it. That's kind of given, though, but anyways. So, if it adds up to 12, that means we have to have a 6 in the middle in the non summed up version, right? Because you have 3, 9, 4, 8, and 5, 7 adding up to those sums. If you add up to 13, you have to have a 2 in the non summed up space line, right? Because then you have 4, 9, 5, 8, and 6, 7 adding up to 13. So that eliminates 2 and 6 in the rest of... Oops, hold up. I accidentally clicked something here. Anyways, that eliminates 2 and 6 in the rest of row 4. So these sums cannot sum to 20 something. Well, they both can't sum up to 30 something unless one of them's 31 and the other one's 13, but that doesn't work because these are 7 digits. That would be 44. So this has to be teens. And it has to be 19, I think. Or 18, because we have to have a 1 on the end. So that means these digits minus the digits at the end is the sum of both of them added together as a total divided by 2. So it can't be 19 then. It can't be 17. 17 times 2 is 34. And 45 minus 34 means these two digits have to add up to 11. But 1 plus another digit can never add up to... It adds up to 10 at most. And it must come up to an even... It doesn't have to be even. Okay, so what happens if we have 19? If we have 19... That means the sum of the digits must be 19 times 2, which is 38. But then 45 minus 38 is 7, which 1 and 9 do not add up to. So this has to be 18, I believe. 18 times 2 is 36. 45 minus 36 is 9, which 1 and 8 do add up to. So these add up to 18. You could have 2, 7, 9 here. That could be the case. Wait. Yeah, 2, 7, 9. That is possible. One of these is going to have a 1, because 2 digits can only add up to a teen number. So this is 1. This is 1. That means one of these. So this is guaranteed to have a 1 here. This is guaranteed to have a 1 here, which means 1 has to be one of these 3 digits. Cannot be there. It must be one of those 2. The sum of this line must equal 45 minus the digits of that sum. And it could be 28 or higher. 28, 45 minus 28 is 17, which 2 and 8 do not add up to. 29, I think it's going to be 36, right? 29 plus 2 and 9 is not 45. 30 obviously doesn't work. 31 plus 3 and 1 is too small. Same with 32. Same with 33. Could be 41, but we can't have a 1 at the end. 41 could have worked. Well, no, it couldn't have. It would be that would be 41 plus 4 and 1 is 46. 42 is too large. 43 is, yeah, everything, yeah. And then 39 plus 12 is 52. 38 plus 11 is 38 plus 11 is 49. 37 plus 10 is 47, and then 36. So it has to be 36, right? 36 plus 3 and 6, which is 9, adds up to 45. So that, oh, this is also 4 and 5 here. So this is a full line at equals 45. This has to be either, it could be, cannot be 11, obviously. It could be 12, 13, or 14, or 15. So this is 1 through 5 here. This is 1 through 5 here. Okay. Huh. Okay. We are guaranteed a 1 here. What's the most you could... You cannot sum to a 1 at the end. So for 5 digits, it could be 2 or 3. For 6 digits, it's 2, 3, or 4. No, it's 2 or 3 also. Right? Because 6 digits can only add up to 39 at most. So we're guaranteed at the ends of this, we have 1, 2, 1, 3, and then another 2. Because we are guaranteed this has to have a 3 here. That means at the ends we have to have 2 and 3s here. And we have to have 2 2s and then 1 3. Because we already have 1 3 accounted for. So this cannot be 2 or 3 here. The rest of column 1 and column 9 cannot contain 2 or 3. That means the rest of row 9 cannot have 2 or 3, right? This is 1 with 2 or 3 here. We have a guaranteed 2 or 3 for the tens digit here. So the rest of row 9 has to be 4 through 9. Okay. This is 4 through 9 here. So we have 2 and 3s already accounted for in columns 1 and 9 for rows 2, 3, and 2, 3, 6, and 9. So the rest of columns 1 and 9 cannot contain 1 through 3. It has to be 4 through 9 there. Okay. Huh. So this adds up to 14 or 15 here. Because of that, this is either 5, 9, 6, 8, or 5, 6, 9, 7, 8, which means we cannot have 7, 8, or 9 in the rest of the row. So this has to be 2, 3, 4, 5, 6, 7 as possibilities. Okay. This adds up to 12 or 13. So you could have 3, 4, 5, 6, 7, 8 here to add up to 13. This can never have a 2. So no 2. This would have to be 3, 9, or 4, 8, and 9, 5, 7, and 8, 6. It would have to be 7, and 7 with 6 or 5. Huh. Interesting. We have guaranteed 2 or 3 here. This is 2 or 3. This is 2 or okay, this cannot. This adds up to 2 or 3, so we have this can't be 2 or 3 here, so we're guaranteed a 2 or 3 here. So we have a 1, 2, 3 triplet in row 9 now, which means this can't be 1, 2, or 3. This must be 4 through 9. Which means we have to have 2 and 3 as some combination here. Interesting. We have a guaranteed 2 in column 9 here. So this cannot be 2 here. Without these 3 digits, you must sum up to this sum. So if this is 20-something, that means these must sum to at least 16. That is possible. How is this going to happen if this is 3? I don't think it can. So if this is 30-something, so this sums up to 30-something. We already have a 3 here. We have at least a 4 here and at least a 5 here. That's 3, 4, and 5 accounted for. So 30, so to subtract that out, 3, 4, and 5, subtracting from 45, would be 33. And then any 30 digit is not going to add up to 3 and 4 or 3 and 5, because it adds up to at most 33. So this cannot be 3. This has to be a 2, which means neither of these are 2. So this adds up to 20-something with 1 and 3 here. 20-something without 2. What's the minimum? 1, 4, 5, 1, 3, 4, 5, 6, 7. That's 21, or it's 28 minus 2, which is 26 at least. So this has to be 6, 7, 8, 9 here. This has to be 20-something. Two, 4, and 5 does not work. That adds up to 30-something. Because if you subtract out 2, 4, and 5, that's 11. From 45 is 34, so that doesn't work. So this cannot be 4 and 5. Can it be 6? 2, 5, and 6 is only 13. 45 minus 13 is 30-something. So 6 doesn't work. 7. 2, 4, 2, 5, and 7 is 14. That doesn't work. 2, 5, and 8 is 15. That doesn't work. So this must be 2 and 9. So 2, 5, and 9 add up to 16. And 45 minus 16 is 29. So that eliminates 9 and 5 in the rest of the column. So this cannot be 5 here because of 5 in the box. 5 eliminates 5 here, so it's 4, which eliminates 4 in the rest of this column. This is 9. So there's no 9 in the row. There's no there's no blonde line in the row, so we don't care about that. That's fine. This can't be 4 because of 4 in the box. 5 has to be somewhere on this line. Okay. So this is also 20-something. Can it be... You could have 6 here. Remaining digits on this line are 1, 3, 4, 6, 7, 8. Yeah, that works. 3, 4, 6, 7, 8, because we already have a guaranteed 1 here. Remaining digits of row 4 are 3, 4, 5, 7, 9. Okay, no 4, 5 here because of the 4, 5 pair in the column. Where is 2? This 3, 6 pair eliminates 3 and 6 in the rest of the row. That's actually pretty helpful. 2 has to be one of these 2 digits here. This 5 digit must sum up to some either... It cannot be 1 because we're guaranteed 1 here, so this has to be 2 or 3. Which means we have a 1, 2, 3 triplet in row 1, so the rest of the digits are 4 through 8. One of these has to be 12. You can't have 13 in both of these, because then that would force this to be 2 and that to be 2. So this has to be 2 here, which makes that 3 here, which makes that 1. So this is 3, that's 1. So these all add up to 12. This can't be 2, it's 6. This can't be 6, it's 2. This must be 2, 7, 9, adding up to 18, which means this can't be 7 or 9. It's 3. This can't be 3, 7, 9. It's 4 and 5, which eliminates 4, 5 in the rest of the box. This can't be 4. It's 1, which makes this 15. 1 eliminates 1 here, so it's 8 and 1. So there's no more 5s in the rest of this row. This is 6, 7, 8, 9. 6 can't be here, so this can't be 6, 9. It's 7, 8 as a pair, which forces this to be 6, 9 as a pair. That means this can't be 6, 7. No 6, 7. No 2, 6, 7 here. That means where's 2 in row 5? It must be there. 7, 8 eliminates 7, 8 in the rest of the box, so it's 9. That's 7. These add up to 13, so it must be 4 and 9. So therefore, that's 3. That means this can't be 3. That's 6, which means this can't be 6. That's 3. No 8 here. No 3 or 8 here. It's 4, 6, and 7. This is 2, 7 as a pair left in box 4. No 7, 8 here. This adds up to 12, but that's fine. We have this remaining digit is an 8. This has to be 1, 4, or 5, but it cannot be 4 or 5 because of this cell because of the 4, 5 pair in the column. So this is 1, which means this can't be 1 here. We have 1 and 3 here. This must be 5, 8, or 6, 7 as a pair. No 5 here, which means no 8 there. No 7, 8 here. No 5, 6 here. No 5, 6 here. We no 5, 6 here. So we have a 7, 8, 9 triplet in column 9, which eliminates 7, 8, 9 in the rest of the column. Also, we know this is 5, 8, or 6, 7 here. So that eliminates 7, 8 here, and this is cannot be 7, 8, 9. It's 5 or 6. This is a 2, 3 pair here. Okay. This is either 3, 9, 4, 8, or 5, 7. No 4 or 5 here, so no 7 or 8 here. This is either 3, 9, 4, 8, or 5, 7. It could be any of those. Remaining digits in box 9 are 1 and 2. It's a 1-2 pair. Remaining digits in column 8 then are 4, 5, 6, and 9. Okay. One has to be one of these two digits. That's interesting. For 5 digits adding up to 30-something, it has to be 35 at most. So therefore, this would be 34, but 5 digits adding up to 34 uniquely must be 4, 6, 7, 8, 9. So this cannot be 3. This must be 2. That's 3. So there's no 3 here. This is 24, 26, or 27. This must add up to 30-something. I think this has to be a 1-2 pair here. This is 30-something, so this must be 34 to add up to for 5 digits. So this is 34, which makes this 5, which makes that 4. No 4 here, no 4 here, no 4 here. So this must be 4, 6, 7, 8, 9. So this is 7, that's 2. 4 eliminates 4 here, so it's 5 and 4. 4, 6, 8, 9, which means 8 cannot be, this can't be 4, this can't be 4. We are guaranteed 8 here, so this can't be 8. 4 and 5 eliminate 4 and 5 in the rest of the row. This can't be 5, it's 6. No 6 in the rest of the row here. We have a 6, 7, 8, and 9 quadruplet in box 7, which eliminates 6, 7, 8, 9 in the rest of the box. This is 1, 3. This has to be 1 and 2. Oh. 2 eliminates 2 here, so that's 1, which makes this not 1. 1 eliminates 1 here, so that's 2. Where's 1 in column 6? It must be there. Interesting. Okay. So this is 34, which 4, 6, 7, 8, and 9 adds up to. We already figured that out. This is 12. That's fine. 45. 13. That's fine. 45. So we have to figure this out. So 1, 3, 4, 5, 6, and 7, again, is 1 through 7 minus 2, which is 28 minus 2, which is 26. So that doesn't work. So if this is 8, so 1, 2, 3, 1, 3, 4, 5, 6. So we have 4, 5, 6, which is 15, plus 1 and 3, which is 19. So this digit must be one smaller than this. Okay, well, where is 9 in column 9 then? It has to be here. So this is 9. This is 7, 8 as a pair. 9 eliminates 9 in the rest of the row. So this can't be 3. This can't be 5 and 7 because of the 5 in the box. This can't be 4 and 8 because of 4 in the box. And 3 eliminates 9 there. What is this sum? It's 30-something. Remaining digits in box 1 are 4, 5, 6, 7, 8. Okay. So to add up to 30-something, it must be these 3 digits. It can't be 36, because we don't have 1 and 2 available here. So it has to be less than 36, which makes it 34. No 4 here, no 4 here. No 4 here. Subtracting out 2 and 6, So it's 34. 11 minus 34. So 45 minus 34 is 11. And these three digits must add up to 11 because these must add up to 34. So therefore, this is 5. That eliminates 5 from the rest of the box and row. So this is 6, 7, 8, 9. Okay. 9 eliminates 9 here. So this is 8. So 1, 3, 4, 5. So 19 plus 8 is 27. So this is 7 and 8. 7 eliminates 7 here, so it's 9, which eliminates 9 here. This is 6, 8 as a pair, which eliminates 6, 8 in the rest of the box. This can't be 6, it's 7. This can't be 7, it's 6. Also, 6, 8 eliminates 6 and 8 in the rest of the column, so that's 9, that's 6. No 6 here. No 6 here. This can't be 7 because this can't be 5 anymore. 8 eliminates 8, 3, 4, and 8 here, so this must be 9 and 3, which means this can't be 3 and 9. This is 5 and 7. No 7 in the rest of the row. No 5 here, so this is 4 and 8, which makes that 7, which makes that 5. 6 and 8 corresponds to 5 and 7 here. This can't be 5 because of 5 in the row. So this is 7 and 6, which makes this 5 and 8 there. 8 cannot be here, so it's 6 and 8. 3 eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 2 and 1. 7 eliminates 7 here, so it's 8 and 7. 6 eliminates 6 here. Here, this is 9. This can't be 6 or 9, it's 8. This can't be 6, it's 5. This can't be 5 or 9, it's 4. 5, 7, or 8 is eliminated here, so that's 6. The rest is just normal Sudoku. Remaining digits in row 8 are 2 and 7. 2 can't be here because of 2 in the column, so it's 7 and 2. We have 4 and 6 here. No 4 here because of 4 in the column, so it's 6 and 4. That leaves these digits as 3 and 9, so that's 9 and 3 there. Yeah, kind of straightforward about these. There are certain restrictions we had about these puzzles, so. But, I mean, execution is kind of challenging, so I would probably place this as challenging difficulty, too. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.